Yes, let's move to the fourth signal, which is x4 of t. Okay, so x4 of t, let us take it to be e power minus at u of t minus e power at u of minus t. Okay, and again, so how does the plot look? So we want the signal to be absolutely integrable, and hence how should the plot look? So e power minus at u of t, we already know that is exponentially decaying function, and minus e power at u of minus t will look something like this, right? But we want minus of that, and hence the plot will look like this. Okay, so this is the x4 of t, but for this to happen, because the curve is going down, so definitely what should be the value of a? It should be greater than 0. And what is the equation of this curve? E power minus at, and what is the equation of this curve? Minus e power at. Okay, so because we assumed a to be greater than 0, the given signal is absolutely integrable, and hence what will be the corresponding Fourier transform? X4 of j omega would be equal to integral minus infinity to 0 minus e power at e power minus j omega t dt, because the first signal, plus integral 0 to infinity, which signal we have? E power minus at e power minus j omega t dt. Okay, so this we have already seen, so this should be equal to how much? Minus 1 by a minus j omega, that is clear why it is so, plus this fellow is 1 by a plus j omega. So this simplifies to minus 2j omega divided by a squared plus omega square. So that is be minus 2j omega by a squared plus omega square. Okay, so let us again talk about the real part, imaginary part, and so on. x4 of j omega we got to be minus 2j omega divided by a squared plus omega square. So this implies, what is this fellow's real part here? There is no real part. Why? It is like minus 2j, it is completely imaginary, and hence its real part is 0. And what about its imaginary part? Its imaginary part would be equal to minus 2 omega divided by a squared plus omega squared. Okay, its imaginary part is given by minus 2 omega by a squared plus omega square. Similarly, what is modulus of x4 of j omega? That should be equal to how much? 2 omega divided by a squared plus omega square. Why? If you take modulus, minus 2j modulus would be 2, and omega will be as it is. And what about angle of what will be angle of x4 of j omega? What would be angular? That would be, yes, tan inverse of imaginary part, which is minus 2 omega by a squared plus omega square divided by 0. So this fellow is a real number. So what you get? Tan inverse of minus infinity, correct? Finite value by 0, so definitely it is infinite. So this should be equal to minus pi by 2. So angle of x of j omega would be equal to how much? Minus pi by 2. Okay, right. So we will take the fifth example, fifth one. Okay, which we will take x phi of t to be equal to signum of t. Okay, so the plot of which will look like this. This signum function we have already seen in the first chapter, right? So it is defined like this. So that fellow is minus 1 from minus infinity to 0, and 1 from 0 to infinity. At 0 it is 0. Okay, so this is equal to 1 when t is greater than 0, 0 when t equal to 0, minus 1 when t is less than 0. So clearly this signal is not absolutely integrable. Okay, so clearly integral minus infinity to infinity modulus of x phi of t dt. Okay, you can prove that this is equal to infinity. So as this fellow does not satisfy a Dirichlet condition, we should say that this fellow will not have Fourier transform. But what happens is that this signal still has Fourier transform. Okay, this signal will still have Fourier transform. How do we get that? So if you remember our previous signal, which is, we will take x4 of t, right? So x4 of t would be e power minus at u of t minus, we got e power at u of minus t. Correct. So how did the plot look? The plot look like this. Correct. For positive, it is exponentially decaying. Even for negative, it is exponentially increasing in negative direction. So this is the plot of x4 of t, and equation of these curves are respectively minus e power at and e power minus at. Now if you look at this little bit carefully, what happens if a tends to 0 here? Correct. When a tends to 0, what will happen? This curve starts moving up, right? So how does the plot look? When a starts increasing, the curve starts moving like this. Correct. So, and this curve starts moving downwards like this. So finally, in the limit when a tends to 0, what do we get? We get finally the plot, it looks like this. Correct. Something like this. What is that plot? That plot is nothing but our signum function, and hence what do we say? Signum function is nothing but when a tends to 0, x4 of t. Okay, so that we will write down. Okay, so we can write as signum of t is equal to limit a tends to 0 e power minus at u of t minus e power at u of minus t. Okay, I'll write down nicely here, times u of minus t. Okay, but what is Fourier transform? So this is our x5 of t, right? Okay, so let us write down what is x5 of j omega. So that turns out to be how much here? Limit a tends to 0. So this, for this signal we already got the Fourier transform. How much is that? Minus 2j omega divided by a squared plus omega squared. So when a tends to 0, this you can write it as 2 by j omega. So what does it mean? The Fourier transform of signum function is how much? 2 by j omega. So this signal will have x5 of j omega, which is equal to 2 by j omega. Okay, so note that we did not use the synthesis equation. Why? The signal is not absolutely integrable, and hence we have to take this route. Okay, so not direct route, but it is indirect route. What do I mean by that? We take the first Fourier transform of this signal and then apply limit a tends to 0. So that will give you the Fourier transform of signum function. Okay.